All right, October 16th, 2025. Here we are. It's exciting middle of October. The colors are changing in the trees, well, at least for us in northern hemisphere anyway. And it's been an exciting week here for me. I've been building all kinds of interesting new tools and launched the Agentic Tribe earlier this week, which was a exciting endeavor to say the least. Had a nice initial cohort, and I got a little. I guess I got a little bit of trouble. Maybe I'm not sure if this is trouble or not, but I apparently I suggested a little bit that we need a bit more diversity, which created a bit of a stink in some of the communities I'm involved in. But I'm willing to take that stink on, and it's I think for me was the right thing to do. So I'm not changing my mind on that. But other than that, the crew is off to a good start. I see Anatole. Good to see you. What's happening? I'm putting you on the spot.
Yeah, like you said, it's cold, the leaves are changing, the wheels are turning, and fi figuring out all of the exciting things to do next.
Yeah,
Or
there's
do you
there's
mean particularly in the tribe?
no, just general chit chat. No,
Yeah, life
nothing
is
in.
beautiful.
Yeah, life is good, right? I'm every day I get up and I realize how fortunate I am to be alive at this moment in time, being able to build and experience and do the things that I have. And I know I'm gonna sound like a crazy sidetrack for a moment, but one of the things that keeps me kind of happy and exciting going isn't the tech itself. I schedule my exercise bike for an hour every morning in my calendar, and it's like a routine. And someone told me the other day that it takes 3 weeks to create a habit, and it takes 2 weeks to break that habit or something. I don't know if that's true, but it sounds compelling, and I'm gonna go with it. And one of the interesting things, especially if you're like me and you work in your office and you don't get a lot of actual human sort of interaction other than this crew is trying to stay sort of mentally effective and excited and positive and for me my exercise routine in the morning. I know it sounds like a crazy thing to say on a tech call, but I'm going to say it anyway. Keeps me moving and smart and on my toes, and I do it more not just to try to stay in shape, but to keep my brain operating at peak capacity. Anyway, interesting side effects for that in how I think and operate. Um, so before we jump into it, I've got a few folks on the call here that I'm going to call out, and I didn't. I'm kind of winging it. So I see Antonella's on the call. You around? See how you're
Yes, I'm
doing.
here. I'm always here for you and for the
Yeah,
community.
yeah. What
And
what do you?
thank you so much for the invitation to for women to join the tribe. I was on the fence even before, but now you made it so easy for me. So excited for it. Thank you. Very generous.
Oh, my pleasure. And what have you been working on?
Oh gosh, I'll be very brief. I was taking the high road with your, platforms and whatnot, but I have so much foundational stuff to fill in because I'm not an engineer. So I took a step back now, and I'm taking actually 5 classes at the moment, so I can fill in the big gaps, the unknown, so I can go back on the lane where you're flying at and try to catch up. Maybe I don't know at 3% of what you can do.
Ugh.
So
Well,
thank you. Really, really exciting. Thank you.
no, and exciting to have you join our tribe. Really do appreciate that. And for those that know, Etienne's working on some really interesting ideas and concepts, and especially in the was it the consciousness space a little bit. Describe this.
Biomedical space, and I'll be happy to bring some ideas. I don't know how the tribes are organized, and I'm more on the non-technical or kind of semi-technical, and so I would be happy to bring ideas on which we can kind of, coalesce, and because it would be difficult for me to attach to something that is super highly technical already.
And part of my thinking on some of this work that we're doing in these, I call them cohorts, but cohorts was apparently too techie or whatever. So then we changed it to tribe, and then people said that I was co-opting sort of indigenous. I can't win. It's not meant to be co-opting anything. It's just meant to be a group of people who get together. But anyway, I digress.
You're
And
you're
the
you're always winning, Ruth. Always winning.
yeah, winning. Hashtag winning. Um, Yeah, so essentially, the idea is mixing people of different capabilities, perspectives, and into a group of sort of like-minded folks who can collaborate in new ways. So that might include a highly technical person, or maybe someone that isn't highly technical that wants to be more technical, or a mixture of other sort of capabilities to see where those capabilities sort of intermingle with each other a little bit. And so if you had a group of all the same people with all the same capabilities, I think you would probably go in a circle. So the idea is by having a mixture of capabilities and perspectives, you can do more together than you can independently from one another. That's my idea, or and maybe it's not my idea, but that's the idea in general. And so again, if you had a whole bunch of people that were just like me, we probably wouldn't go in a straight line. We'd just go back to where we were, and what's the fun of that? So it's a bit of a I don't know, an experiment, and we'll see where it goes. But so far, it's been a successful experiment. So for those that are interested, you can check out the Rube.io site and get a little more. And this is we have group meetings every couple of weeks, and we'll intermingle those in some of these calls as well, where we can. Um, Jed, what are you building this week?
I'm at the moment focusing on connecting directly to a Kubernetes cluster, making and exposing it over MCP in order to complete the feedback loop to extend Spark post deployment.
Nice. I love the stuff you're working on. You're always working on the coolest ideas. Last week's, I still have your last week's Ducky on my list of things to explore. So I love seeing your explorations. It's just fun creating this stuff, right?
It's
All
especially
right.
fun when I get to do things faster and while asleep.
Yeah, while asleep. And the spec is the key to the while asleep. And I'm going to show you guys today a few things on this idea of building things while I'm asleep. Now, I'm going to be completely honest with you. This does take practice, and a lot of the things that I'm building, I'm able to do on a kind of long horizon because I've done enough of it to sort of know how to navigate the obvious pitfalls and challenges that happen in the middle to later stage of these projects. But even that said, it's not like an automatic set and forget sort of approach. We haven't reached the point where it's like, just build me this thing and I'm going to go to bed and it's 100%. Now, depending on the complexity, it might be 100%. But for the things that I'm building that are truly complex, I'm getting 85%, maybe 90% of the way there. Then I'm getting up in the morning, seeing how it works, making a few tweaks, and then I've got basically the basis for what I need to build or show off that day mostly done. So it does two things. It allows me to explore things while I'm sleeping, but more importantly, it makes me excited to get up in the morning and see what the heck it's built. Which I don't know, a nice reason to get up. Not that I need a reason to get up, but it gives me even more of a reason to get up, which is kind of exciting. All right, before we get in though, I see we got Brad on the call as well. Hey, Brad, how's it going?
Hey Ruth, you got me while I was checking my WhatsApp. No, things are going well. Yeah, we're big push on the education front. I built out an education flywheel that will actually create Harvard level courses with a couple of little seeds going in. So I've been busy working on some personal stuff going on there. So hopefully we can get it up to par and bring it up to a level where I can open source it and share with the gang. So
Nice. And how's all your Harvard CS stuff going? I see you're.
I'm you're mentioning the spec-driven development. That's actually my capstone project, is taking messy data, not to your level of complexity, but to take messy data, go through symbolic language for reducing ambiguity. I've done some tests and got ambiguity down from 65% average down to under 2% by going through neurosymbolic language filter, if you want to call it, and then I have the those agents running through, and that's going to be my capstone, which won't be due until April, but everything will be open source once I do have it. So the goal is for most projects, not roof level projects, but for most level projects, you should have documentation that AI actually understands.
Cool. Well, I'm excited to see that, and the work you're doing into symbolic reasoning is really exciting. I keep kind of playing it adjacent. I've been looking at potentially applying the symbolic reasoning structures to the sort of vector and reasoning bank components that I've been working on recently, and defining the symbolic structure directly as a vector rather than specifically as sort of text-based sort of interpretation. Some work to do there, but there's really interesting opportunities when sort of applying latent space along with sort of a symbolic reasoning and how those things kind of interconnect to each other. And I'm going to show you guys a bit of that as well, because this week I launched the reasoning bank system, which all plays into a lot of what Brad just mentioned and the crazy opportunities that we're seeing in the space. Before I jump in though, if anyone has anything they want to comment on, share quickly, or just a general observation, this is your moment. You can raise your hand, or I'm gonna jump in and start taking a look here.
Have we taken a look at a post Claude Code future?
I've been
We're
working
just running
hard.
out until it kicks us out.
Yeah, I've been working. If you notice, a lot of the things that I'm building are actually working towards context sort of mitigation. And Jed mentioned this earlier before we started the call. Is all my MCPs for Claude Flow like fill up a third of the context window before you even hit the first query. So I'm cognizant of that. So I'm working at sort of things like the agent booster and the agentic flow components that basically kind of co-opt the commands and requests before they ever hit the LLM and reduce the reliance on making the request directly to an LLM. So Reasoning Bank does that. All the various tools do are sort of, acting as kind of proxy sort of middleware of sorts that reduce the usage. And moreover, if you look at the proxy components that I've added, it bypasses the need for using Claude altogether often. So I'm actively working towards a world that is not dependent on the most expensive LLM. Even at $200 a month, it's not the most expensive. But as soon as you're trying to use that as like a standalone agent, it becomes very expensive. So yeah, we're all working towards that, I think. All right, a few things that I'm going to jump into here, and if you have any questions, feel free to unmute yourself and just interrupt me, or otherwise put it in the chat area. For those those who are tuning in on different platforms, you can go to our WhatsApp channel to get the Zoom if you haven't. I am not sharing that in LinkedIn today because I've actually shared this to YouTube as well. And those of you know, when I share the YouTube Zoom link, nothing good generally happens from that. So I'm not going to do that today. So if you know where to look, you'll be able to find it. All right, a few things I did this week. So you'll see. So for those who aren't familiar, when a lot of my sort of experiments, you'll see in my gist. So the gist is where I post the sort of specifications. And you'll see here that I've got my flows and my redaction systems and various sort of concepts. One of the things I did, because I was mostly curious, this isn't meant to be a political statement more than just me being curious on how it worked, is I used the goal system that I devised, was it about a week ago, 2 weeks ago at this point, to sort of reverse engineer the ICE and Department of Homeland Security AI platform, which I found really interesting. A couple of things I noticed is I asked for countermeasures to defend against, which apparently was interpreted as me trying to sidestep law enforcement, which is weird given I'm a Canadian and it's not really any laws here in Canada. So obviously the AI has a very American eccentric sort of point of view here. But regardless of that, it did give me a really interesting overview of the structure of their platform. And a lot of what the platform doing is obviously using private vendors like I forget what's the name here, Palantir, in their system, and they're using a lot of the same techniques that we're using it for completely different reasons. But basically, what they're doing is this is straight out of like a sci-fi sort of movie where they're doing real-time evaluations of DMV records and other sort of systems and aggregating it and looking for information and then monitoring basically where you're driving to sort of figure out where you're coming from. And all these, what's interesting when you look at my sort of breakdown, they're all coming from actual citations. So I was doing this a little bit just to see if my citations could ground it and do a decent job. So you can see here that it went into quite a bit of detail in terms of what we know, and known knowns and reason inference. And this is what the interesting part. So much like the way the ICE system sort of infers things based on what it sees, but what it thinks it relates to, it's not actually doing an explicit sort of definition. It's using a kind of pre-crime or inferred sort of view. It's saying that most likely this person is high likely to do a crime or be in this particular location. So it's straight out of like Minority Report. It's like kind of like the idea of pre-crime, and it appears to be able to do the idea of pre-crime quite well, kind of scary well, and based on all these sort of demographic points. Again, not looking at political here. Was just curious on how exactly it was put together. So you can see here, I use the goal-oriented planning. And then for those of you who are familiar with video games, goal-oriented planning is popularized in video games, and referred to as GOAP. And if you've ever used a more sort of complex video game, like, I think Cyberpunk 2077 uses it, and a number of more modern games, it allows the NPCs to essentially sort of interact with the other characters in a way that's more reasonable and realistic through through sort of the information that you've already done. So I've done a different part of the game or whatever. It'll adapt based on it. So I'm applying essentially the same idea as that, but I'm applying it to research. So you can get a feel for all that sort of stuff here. Lots and lots. At the very end, for those who are actually interested in sort of their own version of sort of countermeasures, I was able to create a countermeasure system. I didn't publish the code because I don't want to end up in some, jail somewhere far away. So this is essentially the spec. So hypothetically, if you were going to build a rights preserving countermeasure system, this is how you do it. Use at your own risk. I don't think it's illegal, as far as I can tell, to create systems that provide introspection of secondary monitoring. But like anything, be careful if you do go down that road. Um, the next part I want to show you, let's see what else we got here. We've got, at some point, every AI person goes and wants to create their own weather forecasting system. I haven't actually set the system. Maybe we'll set this up today, possibly. But I was looking at, like, if I want to create a super location-based microclimating system, how would I do that? And the next question would be, why would you even want to create like most of these sort of weather forecasting systems are down to about 25 kilometers, which means it's part of a city or maybe even a whole city, but it doesn't get right down to the neighborhood. What I was thinking is, what if there was a way to really get specifically, like, let's say there's a hailstorm that affects a given part of a city, and there's going to be a particular impact on insurance because suddenly a bunch of cars and roof and windows are broken because of the hailstorm. Can I get that level of sort of granularity and then be able to maybe hyper target advertisements or other things based on what's happened in a kind of real-time view? So that's what I was attempting to do with this specification. So what this is showing you is kind of the art of a specification. So this one is a research-based specification. So think a functional specification more than a technical spec. So we were looking at sort of the latest research in things like neural operators and learning across different scales, and like a lot of what I'm building this using Rust-based platforms. So it goes into, first of all, what GPUs or what libraries are required, that kind of thing, optimization techniques. This would actually be a really good app for some of the stuff Jed's doing with his sort of spot market for GPUs, if you need sort of just quick GPUs to do testing, that kind of thing. So really, really interesting stuff if you're looking at that. I haven't actually set the swarm on this yet, so if anyone wants to go ahead, just copy this URL, and you could probably point that at that. But I'm going to go back here to another one. Let's see what else we got here. So you're getting, oop, I went too far. You're getting a glimpse into sort of the things that are percolating in my brain. This is one that I did 4 hours ago. This is probably what I'm going to do overnight tonight. I'm calling it Poison Pill, a Rust WASM document sanitation. what I'm looking to do here is create a super high-speed document sanitization system. So it turns out most of these LLMs that I've been playing with are susceptible to basically random sort of characters and ASCII that basically makes the LLMs lose its mind. And it's become particularly easy to sort of exploit just about every LLM using non-text-based sort of instruction sets. So things like symbolism and ASCII characters, and we're seeing that there's an 85 and 90% success rate on some of these attacks. It's just crazy how easy it is to exploit a lot of these agentic systems. And I've got a feeling that we're gonna see just a crazy amount of really bad things happening with these agents as they're deployed over the next year or so. So it became pretty clear that I needed some mechanism to sort of avoid that future from happening. So what I'm looking to do here is create this super fast mechanism that sits in between the request of the user or the agent to the LLM, and that includes things like uploading PDFs and documents and other things that's fast enough that you wouldn't even notice that it's inducing any latency. So that's what this specification is doing. So it's basically trying to stop that kind of exploitation from happening. So PDF manipulations, docx, things like that, and provide kind of defense mechanisms against that. And if we look here at the Rust implementation, and Rust is particularly well suited because of the fact it can do really, really fast kind of processing. So I think there was some specs in here. And actually, I built this one just as an FYI using the Claude deep research tool, which is one of the best ones going right now. So you can see all the details. So this is what I would actually feed into my swarm to actually build it. There's a lot of stuff happening here, right? You can see the spec, you can see the pseudocode. So let's use the Spark specification, core sanitation engine. Again, this weak stuff is total BS. This will take like a few hours. So all I really need to do is point it at that and make that happen. All right. Now, hopefully, I'm giving you a quick overview of what I've been working on this week. The last thing I want to show you, where did I put that, is the reasoning system. Here it is, reasoning bank. All right, so the reasoning bank, this is the big thing. And I built this last week actually, but I didn't get around to actually publishing it until this week. But this is based on research from Google. And essentially, what they came up with, and this is similar to my sort of implementation of my SAFLA system I did about 6 months ago. But I guess if you're Google, it has to be in the form of a paper to actually count. But what I'm doing here is I'm basically using my SQLite as a vector database. And so what you're seeing here is how I convert SQLite to be a vector. And now the benefit to using SQLite as a vector is I can run it potentially in just in memory, so it's super fast and super efficient. But I can also run it locally, and I've got 165,000 people who've downloaded Cloudflow that are using my memory, so I can just augment that memory system to include this kind of vector similarities. So you can see I'm getting data from memory items and various components here. All right, so what I'm going to do here, I'm going to do a
Quick
couple things.
question on that.
Sure.
Like, are you using Postgres for the vector database? Because
No, I'm
Postgres actually
using
has it built in.
Yeah, the Postgres, the problem with Postgres is it's slow and heavy, right? So
Hmm.
I'm looking for fast, light, and well, yeah, fast and light. So
And
for certain,
What
SQLite can do
Postgres
that.
Lite, for example, PG Lite, Postgres Lite, or something like that?
Yeah.
yeah, I'm just using SQLite.
What about
How are
So
you
Redis? Because Redis also
representing?
does vectors really, really well.
but it's heavy. It's got a ton of dependencies. It's slow to start. I can start at one of these in less than 10 milliseconds and have a complete vector that exists only long enough for the agent to use it and dedicate it to that one agent or swarm. Now, if
Hmm.
I was going to do that with Postgres, PG Vector, or Redis, or any of the more traditional vectors, I can totally do that. Now, the drawback is they're heavy. They use a ton of RAM. They're super slow
Yeah.
and difficult to run purely in memory, like pretty much impossible to run purely in memory.
How is
So
a vector represented in SQLite?
I'll show you exactly how, and I'll actually pull up. Let me pull up one of my instances, and I'll show you exactly how I'm doing it. Oh, I might have to start it up. Here's Cloudflow. I got it. I got that open. Let's go with that. All right. Ho hopefully I'm not showing my E and V's, fingers crossed. Okay, so this is my Cloudflow development environment. In Cloudflow, you'll see I have a Swarm folder. So the Swarm folder includes a memory DB. So the memory DB initially was a traditional sort of SQL database, and then more recently I added sort of the WoW right ahead of, I think is what it refers to. And we also see that we have things here like my pattern embeddings. So what we're doing here is I can't show you the vectors, not that it would be particularly exciting to see the vector, but these are basically vector embeddings that I'm putting directly in the structure of the SQLite, and then I can call those. So you can see here that I've got different structures that I'm doing here, and I've got multiple pages, and I've actually pre-trained several of these as well. Let me find you the pre-trained models. It's probably even more interesting. So for pre-trained models, I've got things like code reasoning, and we'll go to this vector here. And so what I've done here, so this is the traditional memory and the memory entries. I don't have any memory entries here. And then we have pattern links. So the pattern links allows me to sort of define the interconnected relationship of the different vectors. We've got different patterns that allow me to define the structure of those patterns, what they look like. So you can see here, can I make that bigger? So this is what it kind of looks like. So this would be relating to how the system is doing different code edits. And because it's semantic, I can do lookups based on similarity. So it might not be exactly what I did before, but it's similar. So more importantly, if it's something that failed, it's going to say, well, this doesn't work. And you'll see often, especially with working with these sort of agentic coding systems, that it does the same failed approach multiple times throughout the project, which increases your utilization of the LLM, and it's just doing things that we already know doesn't work. So especially specifically to a project. So if it's already failed, don't do it again. So these patterns are allowing the system to learn what works and then training it based on confidence. And I've set the confidence level to be a max of 0.95 and a minimum of 0.005 or 5%. And as the system learns what works, it basically adds 20 points. As the system fails, it deducts 15 points. And so as the system is running, it's getting smarter and more capable based on those. And so what I've done here is I've created hundreds of patterns relating, in this case, to coding, and using those embeddings as the mechanism to actually allow that to all kind of run concurrently and consistently in a kind of operating environment using the hooks within Claude Code. So when you
That's a
hear this is
really
the Google.
interesting approach to that problem, trying to keep it small like that. Like I have to, it'd be interesting to start to kind of compare it against, like Redis actually set up the right way compared to Redis, like
Redis
by
actually set up the
clicking,
right way compared to Redis,
I
by
want a
clicking.
Docker instance of it, which
I want a Docker instance of
Nope.
it,
depends
which
on how
Imo,
I
you're
add.
hot.
Yeah, we're getting some feedback there for someone.
yeah, we're
All right. I muted them. Sorry. Say that. Say that one more time. Using Redis as sort of an optimization, you're saying?
Well, yeah, because Redis, when out of the box, is set up to solve any problem, but it can actually be tuned to like sub-millisecond latency, depending on like the use case. Like I've done it before. I actually wrote a whole like Redis didn't used to have Sentinel, and we wrote a whole clustering thing at one point to be able to use Redis. This is a different application than that, but like Redis can be tuned to handle this. And I
Yes,
it,
it can be. And I'm not suggesting that this is like perfect for all situations. Like if you were using a multi-tenant environment where you were maybe doing like a agents as a service and you
Mhm.
wanted some mechanism to sort of aggregate all that information, you wouldn't use this approach.
That
Now,
makes sense.
if you were doing an autonomous agent, and let's say you were deploying a swarm of 50 agents that needs to exist just to do some deep research or some implementation, and it's the maximum amount of agents that'll ever exist within that swarm is some nominal amount, 50 or maybe 100. This is perfect. It means you can spin up the agent structure in minutes and have it exist just long enough to do whatever it needs to do and then go away. And while it's doing the thing, it's learning, it's adapting, and it's evolving. Now, very targeted, very specific. It's not it's multi-tenant in the sense there's multiple agents using it, but it's one single user of that swarm. It's me, the user. It's Claude Flow.
Well,
It's a right.
your
So
bottleneck's going to be your file system too, to be
yes,
honest.
exactly. And that's where this idea. Let's go in here, and I'm
Whether
gonna
that's in memory or on disk or whatever, you're just dealing with latency from file access
exactly.
at the end
So
of the day.
the first thing I'm gonna ask here is I'm gonna say, how does the reasoning bank use the I think it's WAL, I think it's what it's called. I don't remember the name exactly. Yeah, WAL in SQLite. So I'm just asking open-ended questions here just to get you the general idea. And what I can also do is have this. I haven't forced it into the Claude Flow sort of default hooks yet because I kind of wanted to let it propagate a little bit and see what bugs and errors before I was going to make it a sort of first-class citizen. But it's completely integrated into the system now, and you can see this if you go in two places. So while that answers my question, I'm going to go here and I'm going to show you. MPX. Actually, I'm not going to use the MPX for this. I'm going, because this is my local environment, I'm going to use the binary. So I'm doing .cloud flow, and I'm going to use this memory. So this is, and when you look at these big, long-winded memory commands that you're getting in Cloudflow, this isn't for you. This is for the agent to understand, the agent and Claude code to understand how to use the system. But in this case, you'll see here that we've got in my initialization. This initialization is essentially inserting those database tables into your.
Hey, Drew, I have a
Yeah,
question.
sure.
You decided to change from the Claude Flow, the NPX, to the local binary. What's the reason behind?
I'm in my dev environment. So in the dev environment, I know that I've got a dist. So the dist is basically bin slash Claude Flow memory. So the challenge I have with building the system is I need to be able to use the system locally without, interfering with the compiled version, which would sort of represent what the final NPM would look like, or the MPX version, which would be a remote instantiation, which could potentially conflict with the development environment. So what I really want to see is how the development environment works, right? So in this case, I can see, just to test quickly, I can run
Yeah, I
this
got
one
it. I got
version.
it.
So this is basically saying I'm working on the alpha. So you're looking at the place where I build it, basically. All right, so a couple questions I had quickly. This is basically the WAL mode enabled during database installation in two key areas. So this is basically provide journaling. So this is write ahead logging for concurrency. So what this means is I'm using that as a mechanism to basically do a kind of pre-cache of the requests, which makes it a lot faster. So again, a lot of what I'm doing is trying to get these things to work faster than the LLM is making, than the request you're making to the LLM. So in this case, the concurrent access means there's multiple readers can access the same database simultaneously. Multiple readers in this case will be multiple agents that are looking to understand how the reasoning bank works, right? It's because the reasoning bank is essentially acting as a training mechanism for the agents. So one doesn't block the next. This is particularly important. And as it points out, essentially for multi-agent swarms accessing shared memory. Now that memory can exist both in on the disk, which it does in that DB file, but also in the memory itself. So that greatly improves the sort of performance of the system. Keep in mind, I can spin up that SQLite library in sub-millisecond sort of increments. So it's instantly on. There's no, and if you try to start Redis or Postgres or any of those things, it isn't instantly on. Like you're lucky to get a Postgres database up and running in several seconds, and that's optimizing the hell out of it and making sure that half the extensions aren't actually being loaded. You add all the other extensions, and you're looking at 30 seconds to a couple minutes possibly to get a Postgres database online. By the time 2 minutes has gone by, I've already ran several billion agent calculations and things just while your Postgres is warming up. All right, so you can see here, so these are some of the benchmarks. So speed, right? It's all about speed. I can do just massive amounts of sort of writes. I can do really, really fast memory. It's I think I tell people that I'm using SQLite, and the first response is like they laugh at me, or like, what the hell, man? But for the types of things I'm doing, it's perfect. It's the optimal sort of vector. Like if I was creating a vector startup today, what I would do is I take exactly what I'm doing here with the reasoning bank, and I'd wrap a kind of vector style Rust library in front of it, and then I'd probably raise $100 million and be the next big thing in vector. But it's literally just wrapping SQLite. So you can see 50 concurrent agents supported. I haven't done more than 50 because I just don't have the budget to go much beyond that. 2 to 3 millisecond query latency, and that's for some of these have several thousand patterns in the database. So speed and efficiency. Now, next thing I'm going to ask, and these are all things you can ask as well. Let's see, how can I integrate? Yeah, I guess spell it right. Integrate the reasoning bank system into the Claude code at settings.json hooks. Open-ended questions. All right, while that does it, I'm going to jump to another thing I want to do. I'm going to let this bake for a minute, but I'm going to jump to another project for a minute. So this is something I've been looking at doing as well. So as you know, I've been working on a agentic payment system, and I've been using it, excuse me, I've been using it for different systems other than just agentic payments. So agentic dash payments, I can remember the URL. Oop. No, I don't. It's not coming up. 1 p.m. Let's see what we got here. Nice fall picture from somewhere there. There we go. Agentic payments. All right, so agentic payments, it's doing actually better than I thought it was going to do. What are we at here for downloads? We're at 10,000 downloads. Not bad for a few weeks. So I'm doing, it's growing pretty good. Yeah, we're at yeah, 8,000 downloads this week. It's funny, everything I'm putting out here just seems to take off recently. I've been pretty lucky. All right, so what this does now is it supports the MCP protocol. It supports AP2 protocol from Google. It supports the ACP protocol from OpenAI and Stripe. But what I don't support is the new trusted agent protocol that just came out from Visa and Shopify and a few others. And so it's got agent intent, it's got consumer recognition, it's got payment information, customer with merchant accounts, prior interactions. So it looks like it would be fairly easy to sort of get working alongside what I've got. So what I want to show you guys is how I go from like, okay, new specification that just came out like yesterday to, or I guess 3 days ago, to actual implementation in a library that people are actually using. And by the way, I get a hell of a lot more users than these guys do. They can only get 28 stars. I'm getting 10,000 downloads a week on this puppy. So I've got the ability to sort of take this and run with it. So I'm going to show you exactly how I'm going to do that. Hopefully this is useful. All right, so I'm going to go back to the agentic. Here we go. Nope, was that the right one? I don't even know. Yeah, it is. Why isn't it showing up? Too many windows? All right, come on. Oh, too many monitors. One sec, guys. All right, here we go. Okay, so fingers crossed I'm not showing any ENVs. Okay, I'm not. So now we can see where so now whenever I start a project, I want to see where I left off previously. So I'm going to I'm doing my DSP-C. This is dangerously skip permissions in Claude code with the -C argument. So Claude space -C space dash dash dangerously dash skip permissions. And this is basically so I don't have to write all that stuff. Now it's the first time I've run it in a while, so it's probably going to take a second to start up. While that does its thing, I'm going to go and start another session. Nope, the system's slow at the moment. Do I have to refresh? I might have to refresh. Let's reload the window. F1 if you're on VS Code, reload. This sometimes happens. I don't know why. Maybe I had it open too long. I'm just gonna just double check. Oh, it worked. Okay, so Looks like I have nothing much. No, there's nothing much here from last time. You can see I've customized down here my Claude code to give me some of the things that I have happening in my environment. I do this just to get a view of what's happening better, and I can integrate my reasoning and memory systems. And so this is basically just hooks. You can see some of these hooks in the Claude Flow folder. I think it's where did I put that in? I don't remember where I put it. I think it's in commands, possibly. No, I don't know. It's one of these ones. Anyway, I'm not sure where I put it. Oh, here, status line. Yeah, this is it. Okay, so this status line is how I do this, by the way. And you know what? I'm going to give you guys this straight up right now while I think of it. So I'm going to go here. I'm jumping around. Hopefully this makes sense to you guys. I'm going to add this to my gist. And we're going to create a new gist quickly. We're going to call it the Claude code status line. And we'll call it status.sh. There you go. You guys can customize this. Just point Claude at it and it'll explain to you what the heck it does. But you can see that it's basically giving me a monitor of my Claude flow and related activities and some other information. Anyway, off topic slightly. Let's jump back here for a moment. All right, back to what I really want to do. So I'm gonna go and use this one, and I'm gonna maximize this so we can see it. Now when oops, when you're starting to do a new implementation, so I'm adding a new feature to an existing tool, and the tool has lots of users. So what I don't want to do is push out a new feature to 10,000 people that breaks it, because then I'll have a lot of hate mail, and I don't want to deal with that. So we're gonna create a new branch, and you guys will be able to see this, and this is the trusted agent protocol. So that's what I might as well just call it what it is. And just for little branding purposes, so I remember where it came from, I'm going to call it the Visa Trusted Agent Protocol. This is my new branch. All right, so now we've got a new branch. I haven't published the branch yet. We'll do that in a minute. And then what I'm going to do is I'm going to create a detailed integration plan. Create a detailed integration plan for the new Visa Trusted Protocol, and I'm going to give it the actual URL. So we're going to go back here, and this is the code. So looks good to me. So we'll post that in here, and I'm going to say something like visit this URL or something like that. Oops, and I gotta go here. Visit. All right. Now, I don't have to do a lot at this point because it sort of knows what I like. I've customized the Claude file in this particular one, and it's using my memory system. So I'm just going to double check my memory system here, and I'm going to go to the Swarm folder and just take a look at what the memory looks like. This is going to give me a view of what's been learned so far as I've developed this project. I'm mostly showing this so you can get a feel for what's happening here. All right, this one doesn't have the reasoning bank initialized. So what I'm going to do in this other one is I'm going to go here, and I'm going to go back, and I'm just going to I'm going to tell it how to do that. Oh, it's a little slow. npx Claude dash flow at alpha, and I'm going to do memory. Now I could do this myself. Maybe I will do it myself, actually, now that I think of it. It might have I might have an old version. I might have to get rid of the other one. We'll see if it installs. No, it looks like it installed fine. Okay, so we're gonna go here and we're gonna run the init reasoning bank. So what this does is it's because I've already have Claude Flow running, I need to initialize it. So I'm gonna initialize the memory bank. I could have got Claude code to do this, but I'm just gonna do it manually because I'm more curious that it actually works correctly. This environment's running kind of slow. I'm not sure why, but we'll give that a second to do its thing. There we go. So you can see here, I've migrated the database. I've updated to include the optimizations for vector, and it should now be in a form that's appropriate. So I'm going to close this down, and I'm going to refresh this environment. Now you see the different tables now showed up. So these are the previous memory runs. So this is all the stuff that I've done to build the application to this point. So it's a significant application. It does all kinds of different things. So every step along the way, I can see what it did and when it did it, right? So this was a write that happened at some sort of point. So every single thing is tracked. Now I've added the ability to do pattern embeddings and pattern links. So if I go back here to my sort of description, I'm gonna go and I'm gonna tell it. I'm gonna tell it here to use the the reasoning system. It should generally know, but I'm gonna tell it anyway. Use the reason, and I'm going to probably add better integration as we go forward. But now I'm gonna invoke it manually. Use a reasoning bank memory system. Uh, um, for optimization of the integration. Um, all right, create detailed implementation plan in, let's see what my docs in this one is, usually docs plans or something similar. Yep, we've got docs plans, so I'm going to go and put it in doc plans and visa. What we call it, trusted agent protocol. And for review, and I'm going to put this in here, MPX memory for details of the reasoning bank system. I'm typing too fast. I don't think it matters, but let's just be on it. Let's just be careful. Reasoning bank system used only for planning and sortation. All right. I'm gonna be explicit. Don't include in agentic payments, or I guess actually I'm in the wrong. I apologize, guys. I'm actually in the wrong repo altogether. Agentic catalog isn't where I want to be. Too many projects. So we're gonna go here. We're gonna go new window. So Agentic Catalog is a project I haven't launched yet. It's a cataloging system that will do all kinds of interesting management for enterprise-focused agentics. It's a great tool, but that's actually not where I want to use it. I want to actually do this in the payment system, so I'm going to have to connect to that. My apologies. All right, so we're going to go and this is going to take a second. So I'm going to connect to CodeSpace. My biggest issue, to be honest, is context switching. I've got too many projects. I literally have hundreds of projects on the go at any given point, and I only have my own memory and has is fully. I need to do like compacting or, I need more context. So classic problem. I was literally in a completely different project that I'd want to be. But regardless, I showed you the sort of background of it. I'm gonna let this run for a sec because I get too much stuff going, so I'm gonna let that do its thing. This is the wrong project, so I'm going to leave this for a moment. And we're going to go back to my other one while that one gets started. Cloudflow, let's see where we are here. All right. Hopefully let me pause for a moment. You guys have any questions while I get my other environment up and running? Am I blabbing or does this make sense so far? All right. Let's see if I got any questions in the chat area.
Hi, Roof. One question.
Sure.
I think you have integrated Google's AP2 into Cloudflow. Is that correct? My understanding.
Yeah, it is the Agentix payment system, and that's what I want to do, but I was actually in the wrong repo. So we're about to
I,
go into the right
I,
repo.
I, I was asking because someone in Google asked me today. Obviously, I shared the link, but I was not quite sure. So, but it is integrated in the payment system. Is that correct?
Yeah, it's right here for those that want to use it. So we go to Agentic Payments. I think I got more users than Google does. Just if you want to, rub that in a little bit, feel free. Um, oh, it is in Agentic's catalog. Never mind. I'm not crazy. Anyway, yes. Point them at this. MPX, Agentic Payments. I've got both support for Google's as well as Stripe and OpenAI's. And after a few minutes, I'm going to have support for the new one from Visa. So one payment system to rule them all. All right, I was in the right place. I just forgot. Okay, so I'm not crazy after all. So let's just go here and we'll go to where the heck did I put it? Probably in the crates folder. Agentic, Agentic payments. All right, I'm just going to include in Agentic payments. So you notice what I'm doing, okay, you see it's Rust, right? So what I'm doing here, oops, is I'm building the sort of high speed, high performance systems actually as a WASM, and then I'm providing that WASM within the actual distribution of the Agentics payments NPM. So I'm delivering the Rust using TypeScript. And then you can run it through as an MCP, or you can run it using the transport layers and various other components. So NPM is actually a really good delivery mechanism because nobody uses Rust, and NPM and NPX is basically a default on Windows, Mac, various, Ubuntu and other Linux distributions. So I know everyone's going to be able to use it really easily. So that's why I'm doing the distribution on NPM. Now, what I need to do, and I got to go back and see where the heck I put it. Right, agentic payments, cargo test, catalog, MBM. Yeah, but here's the problem I face. I can never quite remember where I put that. So I'm gonna go back here and see if I can. It's agentic GitHub. No, that's a totally agentic payments. All right. We're gonna go here. And no, that's just the wrong URL altogether. It should figure itself out here in a moment. I just gotta remember where I put it. Pixel perfect. And the npm library distribution and create detailed plan. I don't know, something like that. Don't implement. Always check the plan before you implement. You never want to do the implementation as part of the planning because then you're just running an autopilot and you don't know what's going to give you. Then this is kind of a hodgepodge of stuff that I'm asking it to do. All right, so
Why do you not use planning? A
because I
shift
don't need it, I
planning.
don't need it, I don't need it in the context. I need it as a plan that I can review. Right. If it's in the planning mode, it's just going to give me the output in the actual UI, which is a high likelihood that it'll run out of context and it'll be a rudimentary version. This utilizes all my various tools. I didn't get it to use the goal system in this case, but because it's already kind of been built. But it allows me to refer to this document folder in doc/plans, which is going to be way more detailed. So now I'm gonna have a folder here called Visa Trusted Plans in plans. So I'm gonna go to the plans folder. And in here we'll see, I guess it hasn't created that yet. So I'll give that a second to do its thing. Oops, refreshing made a jump. I guess I gotta wait a minute for it to sort of come back to life here. So in the meantime, I can click Control O. This is giving me a view. So you noticed what it did is it actually looked at the commands available for the reasoning system. So now I basically told it how to use my reasoning system as part of my plan. So what I'm doing two things here. not only am I creating a plan to implement this new Visa trusted payment system, I'm also infusing all it needs to know about that system directly into my reasoning bank. So while it's doing the implementation later, it doesn't necessarily have to just refer to the MDs that I'm creating in this Visa trusted protocol folder. It'll inherently know the relationship between the things it needs to do later, creating different functions, creating interconnectivity between those functions, and ultimately implementing the functionality itself. It'll be able to refer to that natively as it does the sort of thinking process, and it'll just know. So it doesn't have, I don't have to take that step of parsing, reading, and understanding what it needs to know, and which is particularly important. Every time you get to that compacting, it kind of loses context and where it is and what it's doing. It solves that problem. It doesn't matter if it compacts 1,000 times. It always maintains its sort of state session because it knows how to use my memory system to do that now. So I'm going to go back. So essentially, it's infusing the specification directly into its thought process, which is cool. So you can see it happening right here. So now we're going to hit a Control O again, and we can see here that it decided to initialize it, and now it's inserting the reasoning bank components. And we can see it's doing that for lots of different parts here. So it's creating the embeddings directly in the reasoning system for the implementation, which is, I think, I don't know anyone doing that, to be honest. I think this might be not novel territory. If you know someone else doing that, let me know. But you can see here how it's doing the Visa Tap components, the Visa Tap, and we're watching it do both a plan and the vectors all at the same time. Now, if I go back here to actually look at my actual memory.
You did show, Roop, about obviously the embeddings and the vectors you were explaining earlier on, but then you said you trained it by the penalty or reward system. Um, what does that mean? So I understand the reward and penalty, but how did you go about training those different patterns or that you were showing earlier on?
I'm using a secondary middleware, and that's been compiled using WASM again, because I love WASMs, as you guys probably can tell. And underneath the hood, there's a system that's creatively called Agentic Flow. Agentic flow is what makes it all work. So because Claude Flow has become a little bit cumbersome and big, I'm separating the logic into secondary libraries. So you can see that and you can use this agentic library to bypass Claude Flow altogether. This is doing well as well. I'm on a roll here. This one's got 15,000 downloads already in the first week. Anyway, I think I'm close to 100,000 downloads a week now. But anyway, this is providing the ability to do the agent booster. So the agent booster essentially is the part that allows me to bypass the LLM editing. So rather than getting the LLM to say what needs to be edited, what's happening there is basically a diff. Lines 1 through 10 and 6 through 20 or whatever need to be edited. Right now, and when you use Claude Code or Jules or Copilot or any of the tools, they're making that request to the LLM and saying, here's the code, tell me what needs to change. That's sending a whole bunch of code to the LLM, which fills up and makes more requests. And then it responds with I think it's a JSON style response that says, here's what needs to be edited. That whole process takes minimum of 500 milliseconds to several seconds to actually happen. I'm bypassing that and sending it directly to a local AST editor that I devised that says, here's what needs to change, what needs to change. So I'm going from 352 milliseconds for a single edit to 1 millisecond, and I'm bypassing the LLM altogether. The next thing I did is I added the reasoning bank, the agents that learn. And what happens here is the first attempt, it's going to make the mistake, and sometimes it's going to work, and sometimes it isn't. And when you look at like the Arc 2 or other sort of benchmarks for code editing, you're seeing things like 75 to 80% success rate. That means it's failing 25 to 30% of the time, right? So in this scenario, when it fails, I'm deducting points from the vector itself, saying the probability of this particular edit being successful is 60%, or when it was originally 75 or something, and to a minimum of 5%. I never do zero because zero just doesn't work particularly well. And then I do a maximum of 95. So each time I figure out how to do it successfully, it then trains the system and says, this particular edit or this particular change has been successful once, twice, three times, 10 times until a maximum of 95% is hit. Once it hit maximum of 95%, I assume it's good. And I can get 100% essentially validation that whenever I do that particular thing, whatever it happens to be, I'm going to be successful. Now, I can pre-train the thing to give me sort of the things it needs to know before I do it. What I'm doing right now in this other system. So this is all a WASM. It's a kind of middleware, if you will. What's happening here when we go to pattern embeddings, let's refresh that quickly. Where's a better one to see?
Ruth, are you creating the PRD first, or is the agents creating the PRD on the fly, so to speak?
It's creating it right here. So I'm doing a combination of the PRD. It's not done yet. It's actually still doing research. But in this particular scenario, I'm doing both the pre-training of the reasoning bank and creating the PRD itself. So you see here it says it's creating a comprehensive README. I don't know if that's done yet. Okay, it's going to do its little blinky thing it does sometimes. It's still working on that. Let me see if I can refresh this. So I'm doing two things at once. I'm creating the PRD and I'm training the reasoning system itself to understand what it needs to do when implementing that PRD. So I don't have to go and reference the PRD every time. It's going to reference it for general sort of implementation guidelines. But when each of the agents that I'm going to implement here in a few minutes spawn to actually do the coding, it infuses what it needs to know as part of that sort of coordination of the agent swarm itself, which lowers my requests to the LLM dramatically, like 80 or 90%, because it's looking at the memory bank first before going and requesting the LLM. And I'm saving money. So I don't have one, it doesn't have to do that compacting thing all the time. And my usage goes way down. So I'm building all this crazy stuff and I've yet to be rate limited, or I shouldn't brag because I'll probably be limited this afternoon by bragging about it. But so far in the last month, I have not been rate limited or used up my usage once. And I'm creating crazy amounts of stuff. So
And to
this
be clear,
definitely
you only
works.
have one Claude Max account.
I only got one Cloud Max account.
Yeah,
Yeah.
that's amazing.
Yeah. And I'm building, you guys see what I'm building, like bonkers things. And that doesn't even include all the things you don't see, all my client projects and things that I'm building on behalf or with others and so at any given point, I could easily have dozen different projects on the go, all using one $200 Claude Max account. That said, I'm also now using the Agentic Flow system that allows me to bypass Claude altogether. And so my multimodal reasoning essentially is allowing me to use things like GLM 4.6 and Deep Chat and other sort of LLMs, which are way cheaper as well. So I'm essentially spawning different secondary agent systems that are substantially cheaper. And by the way, when using the router, I find the best, I've tried all of them at this point, is Deep Chat. GLM 4.6 is got some quirks. I'm not a huge fan of it. Um, the Gemini models are amazing because they've got a huge context window. So if you're looking to do more in-memory type things where you want to have a larger sort of memory, you can use a combination of that and my reasoning bank. It works quite well. It's also pretty cheap and fast. So you can see here that some of my speed and performance, and these are I'm actually benchmarking it. I'm using SWE Bench and other things to do that. And the code's all open source, so you can go take a look if you want. If you don't believe me,
Ruth, would it
yeah,
be worthwhile pointing to, like, for example, on Visa and some of their tutorials or information pages? Would that be worth saving into the memory bank as well?
that's what I did. So you notice that I grabbed this URL. So this one gives you a back end and a front end and a tap agent and a few other things. And it looks like let's go look at the tap agent, for example. So we'll see what language it's in. Looks like it's in Python. It's a nice sort of spec language. They're using the different signature system than Google, but they are also using the dual algorithm. So they're using the ED25519, but they've also using the RSA PS hash signatures. So there's some inconsistencies in the hash and the crypto libraries are using. This is the same. This is different. So when we go back, let's go back to the payment system for a second. And we'll see that I'm using the ED25519. This is a really cool specification. I'm a huge fan of it, to be honest. And this is essentially, think of it like a smart contract in a blockchain that doesn't require a blockchain. That's the easiest way to think of this particular. So it basically creates a cryptographic signature of a manifest. The manifest is essentially a contract that says, here are the laws in which you need to work within. So if you want to think of the four laws, this would cryptographically sign the four laws that this system has to work. Don't spend too much, don't do these things, and so on. And it allows it to say if you go outside of those sort of primary objectives, then the system's going to fail and the hash isn't going to work, kind of idea. Now it looks like Visa has adopted that, which is cool. But they've also used this particular one. I think they're using this one because this is quantum safe, possibly. ED251 whatever isn't quantum safe. So they're building for a quantum future where quantum computers potentially break the crypto, which is smart. It's not a bad plan. Anyway, the code's gonna see all that. So we jump back here for a sec. Let's see where it's at. Docs, plans, Visa architecture. Is this? I gotta refresh this.
How long do you think you'll still be using Cloud Code if you're able to use the other models?
I'm jumping around at this point. Looks like looks like something's going on here. What's happening? Control O. Oh no, it's just thinking. I don't know. Claude Code, I like Claude Code for the multi-threaded ability for it to run multiple things really well. But I've moved to the Claude SDK, the Agent SDK, because it does that as well, but it's more programmatic. So for now, I try them all. I've tried Jules, I've tried Codex, I've tried all, but for the things that I'm building, at the complexity that I'm building, it's still the best for me
Hey,
anyway.
Ruth, could I interject here real quick?
Sure.
Are you able to comment a little bit on uh, agent flow, agent flow and Claude flow, particularly like the hive mind slash swarm capabilities? Like what are we losing or what are we gaining by shifting from Claude flow to agent flow, for example?
You're losing the ability to pay $200 a month. Now, that is the primary thing you're losing. And the question really is, well, why would I want to spend more than $200 a month? Well, it depends on what you're doing. So, a lot of times what you're doing is you're building agents for various purposes. So, what I find a lot of my customers are doing is they're building agents in the agents folder that are specific to their business, right? So they're going in and creating an agent that'll run a series of steps that a person might do to do, business analysis or, some sort of, some sort of analytics, people in front of a computer looking and responding to things. So they're using these agents to sort of get it working. So they might create a secondary script that might post it to a Google Docs or send an email to a customer or update a CRM and do other various things. And in that scenario, they get it all working the way they like it. But the problem is, you essentially are invoking the agent here by doing something like an @ sign the agent, right? And that's not good for perpetually running agents. So if I want an agent that's going to trade my stocks, comment on my posts, or respond to my customers, I'm not using Claude Code to do that. I need some kind of agentic system that runs all the time. So then you've got the problem of, okay, what am I going to use to do that? Now, there's lots of agent systems that have popped up. There's big, cumbersome, but popular ones like LangChain and derivatives of LangChain, like Crew AI and others that are built in the Python sort of space. The problem with those, they're really heavy. The architecture is convoluted, and they don't essentially natively support the sort of dot Claude agent structure that we have here that we know works when we run it in Claude code. So for me, it was like, okay, how can I take these known sort of agents and commands that I know we're going to work and always result in the result that I want? It trades a stock, it optimizes whatever it's going to do. So what the agentic flow system does is takes these agents and lets you deploy them as packages that can run in serverless or traditional server environments, Docker, that kind of thing, forever. So at which point I'm then creating a stream of information that I can send to it, or a webhook that sends to it when something is completed and says review or do or check. So in the case of like a stock trading agent, I'm just feeding the agent real-time data from the WebSocket from the stock information provider, or the social influencers, or the whatever I need the information to do, and then it's invoking based on certain introspection. Stocks gone up, stocks gone down. A president's mentioned something, and therefore there could be correlations between what's going to happen. That's all happening in real time. And I don't want to spend a fortune on Claude to do that, because who can afford to have an agent run all the time checking whether or not it's a viable trade? I would lose money, because I'm only potentially making a couple bucks on a trade if I'm doing micro or high frequency trading. So what's actually happening is a couple things. Oh, I hope this makes sense. All right, so first of all, what I'm doing is I'm using the payment system here to define the scope in which the thing needs to operate. So if I'm using an agent that's optimized towards like commerce related activities, trading stocks, buying advertising space, I can say that within the structure of where you need to operate, you can only execute if you have a threshold of probability that the stock trade is going to be more profitable than the cost of doing the trade itself. And that could take in consideration the amount of cost for the LLM, the amount of that goes to the buy or the bid or whatever in the trading platform, or the profitability of the trade itself. Then I can say, okay, that you've made, let's just use a nominal amount, $10. I can say automatically that I've made $10. I can take 20% of that $10 and automatically feed it into the other agent that's basically buying ads or doing more trades or doing whatever it needs to do, managing my treasury, if you will, and have this create this kind of loop between analysis, invocation, buying, trading, selling, and then reinvestment. And all these agents are working in parallel to within their sort of very narrow focus to do those particular jobs. Those are all cryptographically signed and verified in terms of the manifest, or what I call the active mandate, using this particular system. That in turn uses agentic flow to actually figure out what the optimal place to do that is. So when we look at optimization, yeah, I've got the option here to automatically optimize the system to find and determine what the best and most cost-efficient place to do that optimization is, based on the economics and the other things I just showed you. So if it's a low value thing that is not going to make me money, or it's going to ruin my profitability, the system, through the integration of both the reasoning bank, the hive mind components, and the memory components, has contextual awareness of all those things and can automatically make the proper decision to figure out, well, this needs to use DeepSeek, or this is a really high value thing, I'm going to use Claude. Lots going on here, but this happens automatically. Looks like my VS Code crashed. What happened here? I probably ran out of storage. Let's reload the window. So, well, you're gonna see what happens when it crashes. This happens. I probably need to upgrade this machine. It probably doesn't have enough RAM or something. So I'll show you how I'm gonna continue where I left off. This happens sometimes, and this is the biggest challenge to having something run overnight, is when it crashes overnight. Now, to get around this, there is a way to fix this as well. I could run this particular code space in my browser and then have the Claude browser extension keep an eye on it. And when that happens, it'll sort itself out and then reinstantiate itself after a few minutes, which is a nice use for Claude browser extension. But in this case, you guys are watching me, so I'm going to do it. Any comments?
Ruth,
I've got a quick
Antonetta
question.
here. I was gonna ask you very quickly, what do you think about the new NVIDIA personal supercomputer for 4K or so? Would it solve all these problems?
Yeah, I'm like I'm I love NVIDIA and they've been really good to me recently, so I'm not gonna knock on them. But the reality is a lot of the stuff I'm building is building for a future that isn't dependent on GPUs, right? When you look at a lot of the things I'm doing, I'm using the clock cycle within a CPU and trying to hyper optimize at that level, which doesn't necessarily always require a GPU for the things that I'm doing. So a lot of the agents and a lot of the tasks are offloading to things that are CPU or deterministic in nature that don't require a GPU. Now, there's certain areas where you're always going to want to use a GPU, like language models and larger sort of broader models where GPU works well, and that's where a local supercomputer would work amazingly well. So that said, if NVIDIA is listening or watching, I could totally use one of those things. You guys just
The
Wonderful.
DGX Spark is optimized as a workbench to prototype workflows and processes, which then run on the bigger siblings in the DGX family. So the memory bandwidth in particular, I think, was intentionally capped in order to force deployment to the higher memory bandwidth server rack type instances in the DGX family of servers. So look at the benchmarks if you can. So far, not yet impressive, at least for $4,000, or rather, I would have to spend a lot of tokens on an API-based provider for a DGX Spark to make sense.
yeah, exactly. Well
The
said.
only use case is probably for GPT therapists, where I don't ever want those thoughts to go on the internet.
That's a whole other
Hey,
can of
Ruben,
worms. Yeah. Yes. Yeah. Go ahead.
have you ever used any of the quantum computing, like the cloud-based quantum computing? Have you ever tried any of that for?
Yeah.
Yeah.
I've got numerous quantum projects I've done. If you're curious how those work, where are we gonna go here? RuveNet. All right.
So while you're looking for that, just your VS Code runs cargo checks, and that's probably what is slowing it down. When I kill it manually, it starts, working much better. That's what I noticed. So maybe that was slowing your VS Code.
Yeah. I actually like those checks, but I need to do it less frequently. Yeah, here we go. These are some of my quantum projects, if you're interested. Quantum navigation was crazy. I can plot where we exist in the universe using a kind of GPS style navigation. I've got my quantum cryptocurrency, I've got a quantum agentic system, and and I don't even have my QDAG in here. Do I have QDAG? Maybe it's in it. No. Q. Yeah, and then I got my quantum crypto, quantum CLI, quantum network, lots of quantum stuff. If you're using quantum and you're cheap like me, you should use the Azure Quantum service. They give you $500 free.
Cool.
And yeah, and that's how I do all my quantum stuff. And I
I
start with the
I
simulator.
I would I'd love to see you do work on trying to solve room temperature superconductors. I think that's a huge opportunity. I know you've done a ton of things on like security and things like that, but room temperature superconductors I think is a big power opportunity.
Yeah, I'm the problem with that is I don't have a lab, and at which point I start doing that stuff, then I'm definitely in the mad scientist category of AI
Oh
guy.
yeah, no, I was thinking like digital twinning with atomic configurations to try and figure out what was going on. But anyway, that's sort of a
Yeah. Where it's Agentics payment
fanboy
and
idea anyway.
I love it. It's totally up my alley. If I had the capital, I would create a giant lab here where we do like, DC comic style, t tests and experiments. I'd be the good guy, not the guy that turns green and flies around or anything. Um, search for it. Now, what I'm doing now is I don't remember where exactly I created my NPM. This is my problem. I get too many projects. So I'm just going to quickly do a quick search. I don't remember if I did this in the agentic flow system. Too many projects. Oh, it is. I think I found it. Agentic payments, NPM. That's a smart place to put it. All right, so I was right. So I'm not running this blindly. I'm running this with intent, thoughtful. So there's a folder called npm. Let's take a look at the npm quickly. Here we go. Okay, we found it. This is how I do the badges. This is the shield for the tells you how many downloads are getting. This, I'd say the download thing mostly is just to make me feel excited that people are other than myself are using it. I don't know. Yeah, so that looks good. So I'm good to start implementing this. So now what I'm gonna do is I've got the new branch, and I'm gonna can I kill this? Was it Dragon that mentioned how to kill that process?
I think right click or something like that, you could kill it.
I'm right clicking. I can hide it. Maybe
Just give me a second to check, I know that I was killing. Yeah, there,
cancel.
cancel. Yeah, that's
Cancel. All right. I don't need all that stuff. There we go. That was probably your good call on that. Okay. So now what I'm going to do, I'm just going to read it quickly because again, I want to make sure that it's using the existing components wherever possible. So never implement without reading. So I'm going to start with the implementation phases since that's the most likely place to start. The time frames are bullshit. So now we're seeing foundation, agent registry, signature validation. This is the new spec. That's primary thing. I'm just curious what that is. Does, oh, come on. They need to improve their UI. Cloud Code does. What does the uh, it do and how does it compare to the ED2551 spec? All right. There we go. What does the what's I just that's for my own benefit. I'm just not sure what the difference between those two specs are. So establish a registry service infrastructure, implement the it's a 5519, whatever. It should figure that out. All right, just uh, management system, uh, setup.
You feel
Okay,
more
so
comfortable with human in the loop here, always on this part?
always.
Okay.
Yeah, always. What you don't want to be is in a situation where you spend hours, days, weeks and it doesn't work, right? Or you don't understand how it works. So if I don't understand at least rudimentary, at the very least, how it works, then I've got no way to prove that it works. And then there's this blind trust that what it's telling me is true. At least now I know that there's key rotation system, there's a reasoning bank integration. I don't know if I want that or not, but why not? It's a cool system and it could probably improve how it works. Now the core protocol implementation, this is the most important part. It's using the signature-based construction. I'm gonna get an answer to what exactly that spec does here in a second. And what looks to be missing is this doesn't appear to be integrated into the agentic flow npm. Agentic payments NTM. So it's just doing the Rust components. Yeah, it's just doing the Rust components, which isn't necessarily a bad thing, but I want to make sure that it also includes the npm library at the end and the WASM. All right, so I'm not going to implement it yet because I can see there's a couple problems I have to deal with. So I'm going to deal with those first. So now we've got the complementary technologies working together, not competing, which I kind of assumed. For signing HTTP messages. So this is which format comp is for signing authority and headers and how to format signature headers. So that's an interesting approach. Um, then this uses the elliptic curve cryptography. So this is using that idea that I was telling you about, sort of smart contracts. So this is a protocol for signing messages within HTTP requests, high speed. Now that I know that, the question is, how can I use my agentic? Well, I got to check if agentic flow is even installed here. I think it is. We're gonna double check. So I'm going to do npm agentic dash flow version. And I don't remember if this library is installed here, so I got to double check that. I've got a feature in Agentic Flow, which I haven't announced publicly yet, that allows us to use the QUIC protocol, which would look complementary. So how can I use my Agentic Flow QUIC integration with the Or so it's like Lego building blocks, right? I know that there's a complementary protocol here that I could use, but I'm not sure exactly how I should use it. I just know that the two seem like they would work well together. And the where is it? And the ED and the ED from the agentic payments. Payment system. Wow, time's really flying today, guys. Let me just check my calendar quick and make sure I don't have a call here in 2 seconds. Let's see here. No, it would have. Oh, no, wrong date. Sorry, guys. I'm just doing it. We're good. I'm going to continue. All right. So, agentic payments. Agentic payments NPM library. Okay. So this is a protocol that I've been working on that allows me to do a segmented reasoning structure that separates the reasoning model and creates a concurrent stream of like knowledge, comprehension, and insight independently of the primary stream that's giving you the kind of result. So I'm running two concurrent streams of information and then correlating those two and using like the reasoning banks and other sort of coordination, hive mind, swarm components. I haven't published this yet because it's crazy and I'm not even sure how to even describe it, but I know it's there and I think that it's a perfect use case for this particular application. And I do this, that'll allow me to tie all the various parts of the payments, the securing, and the operations of these systems into one concurrent protocol, if that makes sense. So I need to do a little slight exploration of that. And that's what I'm doing quickly before I start the actual implementation. And once I do that, and I'll start this in a minute, I'm going to then get the Swarm to create the update to the Gentix payment system with the new Visa system, probably using my QUIC integration. And do I have that on the website? Let me just double check here. Let's go back here for a moment. Agentic Flow, QU, yeah, no, quick. No, I haven't published that yet. We'll have to publish that later. All right, now it's creating a comprehensive integration guide showing use agenda flow with, okay, then now it's gonna actually write the doc, show you how to integrate from the, I think it sort of skipped my X. So I'm gonna do Control O to see here. Make sure, yeah, it's not using that. I'm gonna stop this for a moment. All right. Review the integration agentic flow. Flow. All right. Don't just do half of what I'm asking for. Do it all. Think I published that? I'm fairly certain I published it. Now I could jump over here. So while that's working, I'm going to go back here and I'm going to try to explain to you guys the QUIC protocol best I can. You can see my benchmarking. So this is how I did my reasoning benchmarking. Where do I get my QUIC? It's probably in doc somewhere. I gotta find it. Quantum. No, it's quantum. Let's do DSP. Reasoning bank. Oh, here it is. QUIC final status. Date's a little off. Anyway, successfully completed the comprehensive research. So this is how I did the research. I did a native implementation. So that should be in the probably the crates folder, I would guess. Yeah, is that it? Yeah, here it is. So this is the QUIC transport layer for agentic flow with WASM support. Um, all right, so now I need to explain it to you guys in a really simple way. So in simple terms, how does the QUIC QIC, these are my plans, which is the final. I'm just gonna go right to the code. QIC actually work, and what are the benefits? Explaining complicated things in simple ways is what I'm trying to do there. I'm going to jump back to my other screen, see what this is going on here. So this is reviewing the agentic flow. It's trying to find I may not have published it yet. I don't, we'll see if it finds it. All right. No, okay, I haven't published it yet. I need to do a push with that. So before I do that, I gotta publish it. All right, so you're going to see me do so. I'm looking to leverage this QUIC high performance networking system that lets agents and communicate with each other other extremely quickly. Here's how it works in simple terms. It's a Rust powered wrapper. The TypeScript code is a thin layer that calls into the compiled Rust WebAssembly code. Rust handles the QUIC protocol. WebAssembly lets you run Rust code. Blah blah blah. Message serialization takes your JavaScript objects, converts it to bytes, passes it to the WASM. Key benefits is the zero RTT connection. Reconnect happens instantaneously, no handshake delay. What does that mean in really simple terms? It means that I'm able to create reasoning systems that don't have any overhead independently of the logic and comprehension structures. So when you think about the separation of these systems from the point of view of giving you a response, like ask a question, which I just did here, and give me a response. In a real-time scenario, I can separate how it thinks from how it operates and have two concurrent streams operating concurrently to one another, but independently in sort of high fidelity. So in this case, I'm sending 100 concurrent messages in one connection. Each message gets its own stream. Now, I don't have the limitations of things like WebSockets or other sort of unidirectional or bidirectional conversational components like a Slack channel. This is all happening super fast. So it automatically refuses connections, it tracks stats, it reduces overhead and creates new connections. So it basically works at a hyper speed, if you will. Think of like, like when you see a movie and the flash is moving faster than a bullet and suddenly time stops? It kind of allows the AI to operate like that. It allows the AI to understand things that are happening very, very quickly, but it allows it to stop to slow it down in a way that's meaningful using these loops that it can understand all the various possibilities of what's happening in real time faster than we can comprehend. We're talking milliseconds. So like basically stops time, allows it to think, and then act on those things while it's operating without stopping or blocking the operations of that thinking process. Sci-fi stuff for sure. All right, now I don't think this been published in the Agentic Flow npm that's live. I don't think I published it. I just built it. So what I'm going to do, I have to, before I can leverage this capability, I have to publish a new version of Agentic Flow that includes this capability, which I don't think I've done yet. Back to there's only so much room in my brain. This is a classic example of I'm doing so much I can't remember if I got to the point of actually publishing this or not. I think I probably created an issue in the GitHub, which I could probably refer to for that purpose. But I think the answer is no. All right, so now what I'm going to do is I'm going to prep this for publishing. And we'll do that here in a moment. And again, the reason I'm reluctant sometimes, this is not meant to be a brag, more of a humble brag. Um, we've got tons of users of this, right? So now all of a sudden I go from like random idea 3 days ago to 11,000 downloads or 15,000 downloads in a week and a half. So I now have to be cognizant of the fact people are actually using it, and potentially I break it and get 1,000 people mentioning that I've broken something they just tried. So I need to make sure I deploy this in a way it's not going to break. All right, so what we're going to do, no, the queue is not fully published yet. Here's the current status. TypeScript source, Rust implementation, compiled JavaScript, git commit mentions fixes. What's missing, WASM is not built in patch. Okay, so what we're going to do is we're going to do this. All right, build the WASM, verify it works, prepare and integrate into the agentic flow npm, validate it works using a Docker instance to simulate a remote environment. This is an important one because now that I've got all those users, I want to make sure this works remotely. So what I'm doing is I'm basically getting the system spawn up Docker instances to kind of install it and make sure it's not overtly broken. And it works. Update the npm package with a point release. Update the readme.md to include reference to the new capabilities. And finally, create a GitHub issue with details of the latest updates using the CLI. All right. And I'm not using a swarm, nothing like that. I'm just do these things sequentially because they kind of need to be done one at a time. So I need to build the WASM. And I think I got the WASM working, but I don't remember. So I need to go and do a double check of the WASM. The WASM takes the Rust, compiles it into a self-contained binary that has no dependencies. And then once I've got the WASM, think of it as like that .bin or something. Then I'm going to take that, I'm going to put it in the npm npx package, and I'm going to distribute that using the npm, and then I'm going to leverage that WASM, which has no external dependencies and it's highly proficient and performant. Then I'm going to use that within the npm whenever I need to use this kind of advanced cross networking component that allows the AI to more effectively communicate with itself, swarms, hive mind, reasoning banks, and my new payment updates, which I'll do once this is published. So before I can publish the payment updates, I need to publish this particular feature. Once I've got that, we're good to go. So I'm going to let this build for a minute. I'm going to jump back to this. And I'm going to say the Q protocol and how I can use it with previous. All right. This is me killing some time. It doesn't know what it's too new a protocol for it to even understand what the protocol is. But basically, let me try to explain it best I can. So in the internet, you've got multiple protocols that are available. You've got TCP, which is kind of the primary protocol of the internet. Think HTTP, HTTPS, port 80, port 443, that kind of thing. And you've got secondary protocols. In the early days, you had things like Gopher, you had FTP, now you got WS. And these are protocols that exist as secondary sort of protocols to HTTP. Now, one of the other protocols that are popular but not used because of consistency issues is something called UDP. So TCP is the packets that get sent in HTTP and whatnot. And the problem with that is when one packet gets delayed for whatever reason, your internet goes down, your mobile connection connects to another whatever problems, it creates a kind of backlog, right? Rather than concurrently saying this particular request failed, it basically stops all other requests from happening, which is creates problems when you're working in concurrent or parallel applications like a swarm of AI agents. Now, I could use something called UDP, which allows me for a kind of eventual consistency. But the problem with UDP is there's no validation of those. So packets will get lost, and there's no validation that the request was ever successfully sort of finalized. The QUIC protocol allows you to solve all those problems of UDP where it allows for consistency but no validation that it was ever done. And it does so in a really high performant way. And it's a specification that the internet, the guys that control the HTTPs of the world are now implementing broadly. So it's supported in various browsers and applications and things that where I would need to utilize that. So in the docs folder, under plans, we see that there's a folder called QUIC. This is where all my research to do it is. So, and this is, I think I published this on the site. You can probably dig through it and find it. But this is the initial PRD to Matt's question. So this is the sort of core protocol itself, how it works, streaming, multiplexing, and UDP transport. I probably butchered the explanation, but you can see it does reference it. How the handoffs work, that kind of stuff. Then there's a README. This is my actual implementation. So this is showing you how I'm taking that and like some of the benefits is 2 to 3 times faster for connections and handshakes, streaming, multiplexing, connection pooling, auto fallbacks, health monitoring, TLS 1.3 built in. So this is encryption where UDP doesn't inherently have encryption. This is high-speed encryption, which is why it would work so well for the payment system. And here's how the system has been implemented. This is the sort of technical details. We can look at some more details of what it was done, how I validated it. So I basically built this system as a Rust library to start. And we can see here.
Do you use agents to do your validation, or is it really a human
I
checking
do.
this out?
Oh, I do both. This is hundreds of thousands of lines of code, so it's way more than I could possibly, validate myself. So I'm using test-based validation. See, 95% design target, test targets, and then I compare it against the official specification. And then I've got these different benchmark scenarios, 10, 100, 100 concurrent agents. So I'm using Claude Flow and Agentic Flow as the basis of spawning those agents. Then I'm looking at network latency and projected versus actual results for memory usage. Um, Here's some of the problems it ran into. Now, most of the problems what's an actual Rust. Oh, this might be an old one. I think this might be older. I think I've actually done this. I need to update this, but this was an early sort of test. I probably need to look at the final one, but you're getting an idea of where I am. Let's see what we got. What else we got here? Oops,
Ruv,
why
are
isn't it?
these the docs not published on purpose?
They're published. I might not have published this branch yet. You gotta check whichever branch it is. Feat QI optimization. I might not have published the branch.
When
I can
in
publish this
Brent,
branch now.
oh, the docs looks empty on GitHub.
You're remember I do all branch. Does this branch exist?
No, that one is not published yet.
Yeah, I haven't published it yet. It's a work in progress. I can publish it for you guys. I'll get this up and going, and I'll publish this and do a PR later this afternoon. What I can do for those who are on the call who are eager, I'll do update. There, that's just for you guys. Let me just double check. I'm not publishing anything I shouldn't. No, it looks like just reorgs mostly. Okay, we're good. All right. So I'm going to publish that. World's worst pub message, but just for you. Okay, so now if you go to my repo, I'll show you guys where to find this quick. It's a work in progress. I'm not done. So you're getting, if you like alpha, then you're getting the alpha. But you can go here to the Agentic Flow site. And if you go to here we go here. All right. Oh, we'll go to is it showing up? Oh, why does it keep jumping? QUIC. Well, no, it's not showing for some reason. No, it crashed. I apparently did too much. It crashed. No, no, it didn't. Did it crash? No, I can't push refs to promote. I got differences. I'm gonna have to fix that separately. It didn't publish.
What I was seeing, just even in the main branch, the whole docs folder seems empty. There's nothing else there.
Yeah, look. I probably just didn't do a PR. Look at the branches. You're probably just looking at the main branch. You see all the other branches? This was updated last week. This was updated 5 days ago. Go with the 5 days ago. We'll take a look. This current branch is failing. There's some sync issues I gotta look at. Let's take a look here. Yeah, this one. Maybe I've excluded docs, possibly. You're not seeing docs either, right? Yeah, let's
Right.
take a look. Yeah, same problem. Let's take a look here. Plans, docs. Yeah, I don't know why it's not showing. I'll fix that later, I guess. Yeah, it looks like I've been a little overly zealous in my cleanup. Let's move that into docs as well.
It looks like a symbolic link where maybe somewhere else.
Possibly. I do that. I've been known to do that. There we go. I'm moving that. I'll fix that up for you guys in a minute. Right, I'm doing the build of the WASM, so I probably want to wait a few minutes. It's Now what's happening here? It looks like the WASM directory was created, and now it's attempting to compile. Looks like it did eventually work. Now it's creating a Docker instance to validate that it works. Oh, all right. Yeah, this is like a cool feature if you're like a super infrastructure AI nerd. Like I don't think the average AI person is gonna have any idea when I start talking about QUIC what the benefit is. So it's like I'm not sure how to present it to the world. Other than I think it's pretty cool. At least I do. But let's see what else we got here. Just let's go back here. Let's go to my issues. Yeah, here we go. You can see all my implementation plans. Yeah, so I did. So I output the entire development process as a series of steps. So for those who are interested, I will get this published in a bit. But you can see here that here's how I did the reasoning bank. So this is the initial reasoning bank PRD. So you can see embed, fetch. Yeah. So if you're curious how I built the reasoning bank, this is it. This is the issue. I'll post this for you guys. Yep, so you can see judge the LLM as a judge. You can see how I'm hijacking the requests. You can see how I'm storing the vectors, the memory structure, the dedupes, the contradiction detection, pruning strategies, the memory aware test time. This is really cool stuff. This allows it to, remember I was telling you about this idea of sort of bullet time? That's the bullet time. This basically allows the LLM to perceive time differently than how we perceive time. It allows it to basically slow time down, conceptually understand what's happening, and then go back to normal time, which is just crazy that we can control the perception of time within thinking models. It's bonkers. Here's the sequential mode. So this allows it to understand how to interact with the other concurrent thought and reasoning processes. This defines guardrails for how and what it needs to do to distill failures, positive, negative values. So it's a self-reinforced learning system that doesn't use traditional model-based learning. It uses a vectorized learning component, which is way more efficient than trying to stuff in a neural network and train it. All I'm training is the memory. So I'm training it what to understand and how to understand it versus trying to fundamentally change the inherent architecture of the neural network itself, which is way faster. Then we see there I've done some basic web arena benchmarking. And so I'm validating. Here's the core tables, which I showed you earlier. This is how I'm actually defining the actual vector that exists within SQLite. And you could totally take this, by the way, and put it in Postgres or whatever you want. It's the benefit to SQLite is to work with any SQL style database. Practical advanced applications. So this is like how the heck are you going to use the thing? One thing to note, by the way, in terms of my reasoning bank implementation for Agentic Flow versus Claude Flow, Agentic Flow is doing it in memory. Cloudflow takes what I'm doing in memory in Agentic Flow, uses it as a secondary dependency, SDK style dependency, and then re-implements that into a memory.db file locally as well as in memory. So this is all in memory. And it's meant to be in memory because it sort of sits somewhat independent of the secondary libraries that I want to infuse with the reasoning bank capabilities. So this is basically telling it how to do stuff. Let's jump back here for a moment.
Ru, are you using this reasoning bank for your personal use cases, like as a secondary brain for the prompt enhancement, or like referring to alt promptings, which you did on the LLMs?
I'm using it for secondary contextual awareness and optimization. That's a pretty broad statement. So what I'm really doing is I'm attempting to redefine how it thinks, why it thinks, and what's meaningful for when it does think. And that means that I can use it for any kind of anything that would involve any kind of logic or comprehension within the structure of my agents. Should I do this? Shouldn't I do this? Has this worked before? Will this work again? And as it does those things, it'll refer to its memory before it goes and asks the LLM for what it should do. If it's done the thing before or understands why or what, it won't go and make the request to the LLM. It'll just use its own memory, which saves me substantial amounts of, LLM usage and whatever.
Yeah, but
So
I was asking for, like, rather than the agentic orchestration, I was asking for, like, when you are prompting the LLM, maybe it can first query the memory bank for the previous queries and prompts, and then can understand your intent from that small prompts
yes,
and
yes,
do
I
the
think
enhance.
yes. So it's semantic. So when I say semantic, what I'm really saying is it uses natural language and semantically defines the request based on what the semantic meaning of that request is. So the problem with my previous memory system was it was deterministic. It was explicit that it remembered everything, but in order to get those memories, it needed to know what the namespace was, which I tell it, and then it needed to query it, which was a little bit, it was fast, but it wasn't specific. When I started creating an interconnected relationship of vectors, I created a graph that says, here's what works and here's what doesn't, and here's how it's related to everything else in the system using a sort of semantic understanding of what it is and what it's connected to, which is kind of like how you think, right? It's how your brain works. It's like when you think about something, you can kind of understand how, when you thought about that thing, how it relates to the other thing you're thinking about.
I
All right,
see.
so one last part here. So this is the QUIC protocol research. This is me telling it that how QUIC works. Transport layer, it's telling it about the payments and how it can sign mandates in the first packet. So I'm doing mandates that are embedded in the request of the packet in the data itself. So it's in the lower level operations of the network versus the sort of client side, which is a way faster, more efficient way to handle it. So I'm embedding agents in the very fabric of the internet um, lower networking levels, which is just insane. And then getting optimal sort of first connection in 300 milliseconds and going to 100 milliseconds according to this. I think I can do better than 100 milliseconds, to be honest. I've seen it as low as like 2 milliseconds. Resume connection. So if something fails, so let's say I've got an edge-based agent and it's got problematic connectivity. Maybe I'm using like a 3G modem, and it can resume without so it's fault tolerant. Multi-agent, works in parallel. So it's hyper optimizing the intercommunications of the system through cryptographic structures that sit in the underlying networking components of the internet. All right, so that sounds cool. Let's say update the protocol plans to include the QUIC. All right, I gotta jump to a call here in a couple minutes, guys. QUIC, and I'll use the forthcoming agentic flow. Maybe I spell that right. I never spell agentic, apparently, correct? Agentic. All right, agentic flow, npm, and WASM. All right, so I'm just giving you a little head start there. I'll revise that once this is done. And we are done. All right, let's see what we got here. I've successfully built and integrate the QUIC transport layer in the agentic flow package. All right, publish. I'm going to publish this just for you guys. Publish the branch and update the GitHub issue. Oh, it's already updated. Issue number 23. So we'll go there. That's for you guys. I'm running out of time here. Here we go. So I'm not going to update the issue. I might have to double check what's in the git ignore. It looks like some of the files are being excluded, so I might have to do a double check on that. You'll see. But basically, you're getting a verified WASM, you're getting the updated package. I'm getting 50 to 75% faster than TCP. That's crazy. Like this is a whole networking startup that I just devised just because. Zero RTT connection establishment, instant reconnects, stream multiplexing, 100 concurrent messages, built-in TLS encryption. This is like in the area again of never been done. Like it's just because we can. And I'm gonna push this, and I'm gonna do a little bit more testing on the package, and I'll push this out this afternoon for you guys. I'm out of time. Hopefully, 48 people left, so you guys stuck with me.
Thanks, Ruth.
It was good, Ruth.
Yeah, so you're gonna see a bunch of new updates. You gotta get a little peek behind the window of what we're doing. I'm working on a new version of the Agentix website for anyone interested. We'll hopefully launch the new homepage with Brad and Matt and others later, maybe early next week. So maybe I'll give you a sneak peek of that on the AI Hackerspace tomorrow. Yeah, there's just limitless stuff to build. And I'd be curious if you guys use this stuff, and specifically the reasoning bank stuff. Let me know what you do. Like if you want to try implementing the reasoning bank in like Postgres or Redis or some other system, just install a Agentic Flow and then point it at Claude and say, implement this in PG Vector or something. And it'll just go and do some crazy stuff.
You
That's it for
suggested
me.
DuckDB, which already has a well-built WASM. So I am curious to
I've
see how that would work
I've
out.
I've struggled with DuckDB. That's a whole other
DuckDB
can
is
of worms.
predominantly an analytics a query runner. So it's not really meant for key value stores the way SQLite is.
It blocks. There's a lot of blocking issues. SQLite just kind of magically works with the right with WAL, whatever, right after whatever,
Write
and
ahead log.
yeah, right ahead lock. It just works. It's light. It's fast. Sometimes the simplest solution was that Occam's razor is the best. There. I think that's where we're going to end today. Any mention of Occam's razor definitely is a place to stand. Thanks everyone for tuning in. You guys, I love sharing what I'm building. You guys are just getting a glimpse into the crazy stuff I do at 2 o'clock in the morning. That's it for me.
Thank you. Super valuable. Have a great one.
Yeah, see you guys tomorrow.